Welcome to the deep dive. Today, we're doing something a little unusual. We are dissecting just one single piece of industrial hardware.
Yep, just one. The NTI E-BEEP1-600 rugged miniature piezo alarm.
And our mission really is to see what its specs can tell us about what goes into these high-stakes critical alert systems.
That's right, because fundamentally, its job is simple. It just emits a very loud, continuous tone.
To warn people or scare off intruders, I imagine.
Exactly. And the key spec here is its loudness. It's rated for 95 to 103 decibels at 2 feet.
Wow. Okay, 103 dB is. That's a lot of noise coming from such a small device.
It is, and it has to be, because we're not talking about an alarm for a quiet office.
Correct.
This thing needs to be heard over, running machinery, HVAC systems, maybe even industrial generators. It has to cut through all that ambient noise.
Okay, so let's zoom out a bit. This thing is tiny, 1.3 by 1.15 inches,
Just about.
and it costs $205. So
Yeah.
is most of that cost just paying for the absolute guarantee that this thing will not fail?
Precisely. You are paying for engineered survivability. The whole thing is epoxy encapsulated, it's polarity protected.
Meaning it's sealed against what? Physical shock? Electrical screw-ups during install?
All of the above. You're basically buying guaranteed function.
So that brings us to the certifications. I saw it has both ASTM B117 and an IP68 rating. Isn't that a little bit of overkill?
You'd think so, but no, it's actually about comprehensive defense. IP68 is the highest rating for dust and continuous water immersion.
So if a pipe bursts or the area floods.
Exactly. But the B117 rating is totally different. That's for salt spray and corrosion resistance.
So for more chemically aggressive places.
Right. Think marine installations, chemical storage, maybe even ammonia freezers. You really need both to cover the widest range of potential failure.
And you couple that with the operating temperature. It runs from -4 all the way up to 149 degrees Fahrenheit. So it's built to live in a commercial freezer or, blazing hot telecom cabinet in the desert. It's an indestructible sound machine.
And this is where the logistical side gets really, really clever. The power and the distance.
Okay, yeah, this is where it gets really interesting. It's powered by a simple 2-wire interface, but it only consumes 50 milliamps. Why is that low number so important?
Because of the maximum cable length,
Which,
1,000 feet, that's over 300 meters.
wow.
If the alarm drew any significant current, you'd get a massive, totally unacceptable voltage drop over 1,000 feet of wire. It just wouldn't work.
So the low power draw is what guarantees it'll actually fire at full volume, even from that far away.
Exactly. It ensures signal integrity across these enormous distances.
And 1,000 feet is staggering. I mean, in the age of tiny wireless IoT sensors, it feels like a legacy solution.
Well, it is, and that's the point. It's for vast industrial sites where running a new power line is a huge expense, but running a simple wire pair is doable.
And I guess all the other details, like the RoHS and UL approvals, the 2-year warranty,
Yeah.
that all just reinforces its role in professional, critical jobs.
It all points to certified, guaranteed durability over time.
So if we step back, what does this deep dive into one tiny buzzer teach us? It seems to be built on this kind of design paradox.
How so?
Well, first, you have this extremely small physical size, but it's coupled with this immense acoustic power, 103 decibels.
Okay.
And second, it has this absolute certified resilience to survive pretty much everything. Corrosion, full water immersion, extreme temperatures. It's the cost of reliability.
Indeed. And this raises an important final question for you, the listener. If we accept that this tiny device has to work reliably 1,000 feet away from its power source in a place that might be corrosive or even flood, what failure scenarios are the engineers actually trying to prevent? Are they just worried about equipment failure? Or are they worried about the failure of human safety protocols in the most dangerous remote corners of an industrial world?